Good evening, everyone. That was a good first one, but I know we can do better. Good evening, everyone. All right. It's the day after a holiday, so I get it. Welcome to Astronomy on Tap, number 35. So, yeah, we're working our way up. Huh? Oh, yeah. Thank you for all of you for coming. How many of you, is this your first one ever, first AOT ever? Well, thank you. Wow. Thank you for coming. Within 5. Okay? And then plus 5, more than 5. Wow, lots of regulars. There we go. Good to see. Well, no matter what, thank you for coming, everyone. Welcome. Tonight, we've got some great talks for you, of course. As always, our hosts are myself, Michael Velez.
Aaron.
Sam.
And then we got Adam and Brian, our tech geniuses. Frank, whoever I don't know why we have music today, but there's always... Actually, no, this is Duran Duran. James Bond, Duran. So... always a fun wrinkle. And then online we have Thomas Lechner, and then Tracy Becker is watching virtually today. She is on travel. So we're your team, and we're going to get started. I know it's getting louder. And this is... All right, Aaron.
All right, so... what is Astronomy on Tap? It's an international event. I believe it started in the States, but just lots of scientists go around, pick a bar, and say, hey, let's do some outreach. Let's get the public involved. And what we do, we have fun. It's mandatory. And it is interesting. We have lots of science talks. We have talks from SWIRI, or Southwest Research, I should say, from UTSA. Hopefully, every now and then we have some visiting scientists come down and give some talks whenever they're here. It's interactive, so we'll all learn. For the first-timers here, the music just gets louder. The first-timers here will all learn the tradition later on that we have. And then also we have a chance to win. We have trivia at the end, so if you're interested, stick around. You have a chance to win some prizes. There are some rules to the trivia. It's mostly for the ones who are students and are professionals. We like to have them challenge each other to keep the public in the running, I should say. And then so, Sam will give you your AOT tonight.
Oh? All right, we'll just not talk the whole time. Today, we have 2 excellent talks, but they couldn't show up, so we got these guys instead. Our first presentation, the title is small this time, Total Occultation of the Heart, but the name is huge, by Dr. Anicia Arredondo Guerrero. That's my American bastardization. Then we'll have a break, followed by Caleb's Astronomy in the News. And then finally, great clips. The Moon is Getting a New Dew by Elena Dolgas, who recently got her master's degree. So our first speaker tonight, next slide. I can do that, can't I? Boom. All right. Dr. Anicia Arredondo Guerrero is a planetary scientist who studies small bodies in our solar system. She uses telescopes to search for evidence of water on asteroids and the moon through infrared spectroscopy. She grew up in San Antonio and attended graduate school at the University of Central Florida. Any Floridians? And now she's come full circle back to Southwest Research Institute in San Antonio. There we go. Without further ado, I present Anicia with Total Occultation of the Heart.
Thank you. Well, we gotta be brief and weird. You could just tell them. Hi, everybody. I would like my slides, please. Drinking word, yeah, drinking word. What did I say I wanted? Shadow. We're going to talk about shadows tonight. I take any opportunity possible to let people know that I'm over 18 years old. Oh, sorry, let's explain shadow. Every time I say shadow, you take a drink. And you yell woo. And you get really happy and hyped about science. Yeah, okay. Yeah, I'm over 18 years old. I've heard total eclipse of the heart before, but I changed it because occultations are cooler. What is an occultation? What a stupid word. So we've heard a lot about the eclipse, right? Everyone's super hyped for these 2 eclipses that are coming up in San Antonio. We're all, yeah. Okay, so in an eclipse, the sun is occulted by the moon. You're so close, so close. Okay, so the moon is in between the sun and the earth, and so what we end up seeing is a blocked out sun. We can only see the corona. It's beautiful, it's amazing. Everyone should definitely go see it because you only have to drive like 15 minutes if you want to see it next year. An occultation is a little bit different. Instead of the sun, it's a tiny little star super far away. And instead of the moon, it's a tiny little asteroid. But the same thing applies. It casts a shadow on the Earth. And so if you're looking at the star over time, you're seeing the star has a certain brightness. It's always the same brightness. But once the thing passes in front of it, all of a sudden there's a giant dip in the brightness. And so the size of that dip can tell you stuff about the shape of the object or the how fast it's moving, its orbit, a bunch of stuff like that. So it's super duper cool and awesome. And the length of time of the dip tells you about the shape, which I just said. And so see, this is a schematic of a shadow being cast uponst the Earth. And so what you want to do is you want to get, is there a laser? Yeah. You want to get multiple observatories in this shadow path. And so here we have 3 different observatories, right? This first one, the asteroid is moving this way, which means the path of the shadow is moving that way. I'm not going to get you drunk, I promise. So this green observatory sees it first, right? And so if this is time versus brightness of the star, the green thing sees a dip before the other 2 places. Observatory number 2 is dead center in this path, and so it gets a longer dip than the one that was off to the side. Because see, this is the shape of the asteroid, and so the length of time of that dip tells you how long across the body's axis you're measuring. And then observatory number 3 sees it last, and it's pretty long because this is a wonky shaped asteroid. Asteroids are all little weirdos. So why do I care about this asteroid's little tiny shadow? I get that you made a career out of this, but this has nothing to do with me. Well, it's just cool, for one. This image here is actually a bunch of different people measured this dip in brightness over time, and what they did, each of these lines is a separate observer. And when you put them all together on a map, it literally makes the shape of the asteroid. So this is the measurements from the occultation, and then this is a shape model that you get after that. And you can see this guy's weird. He looks like a bean, but this guy's kind of circular and cool. Oh, that sounds so much better. Nope. Sorry. Yeah, okay, so that's something awesome that we can do with occultations. There's also James Webb Space Telescope just measured rings around a tiny little asteroid and super far away. This image here is a little movie of the photometry, and you can see the little star gets faint now. And so what happened is the star is up here, and what we saw is brightness and then a dip, and then we missed the main body because the telescope wasn't in the right place at the right time. But then we see another dip. So we saw rings around something super, super, super far away that's super, super tiny. We also learned about Pluto's atmosphere via occultation measurements. Way back in the 80s, or 70s or something, I wasn't alive. There's people, and they, devoted their whole careers to measuring occultations of Pluto. Pluto is super cool. It's the coolest thing in the whole sky. But what they found is that if you have a body moving across a star, you get that dip, like I told you. But what they actually saw was this kind of, it's not instantaneous. It goes over time, which is actually caused by light rays are coming through and getting refracted. And so instead of a fast dip, you get a slow dip. And so that's why this is angled. Does that make sense? Okay, awesome. Yeah, so that was way back when we didn't even have, James Webb and all these super awesome things. Like, we were able to get really cool information from occultations. And this is my favorite image from the New Horizons spacecraft. It's Pluto with the sun in the background. It is an occultation, and you can see the blue haze of the atmosphere, and I just think that's awesome. So, like a solar eclipse, you have to be in the shadow path if you would like to see an occultation. And so sometimes the shadow path will be over America. And that's awesome because we live in America. Sometimes it'll be in other countries. That's cool too, because then you get a free trip. Sometimes it's over the ocean, and that could be cool, but if you can't swim, then probably not. And so you want to have a bunch of telescopes along the path. You saw the image earlier where we had a bunch of tracks, and then we were able to get the shape of the object. This was an occultation of, I think, Pluto. The line is going to be the path that you want to be on if you want to observe it. And so there's one telescope in Brisbane that's kind of close, and then nothing else. So what do you do if you want to go to the bush of Australia and observe this thing if there's not a lot of telescopes there? Oh, yeah, you need a lot of shapes. What you do is you get NASA to buy you 100 of these little tiny telescopes that are super portable. And then you also convince them to pay for you to go on a trip to use the telescope and observe this occultation. So originally these were bought for the New Horizons mission team. They had a giant observing campaign. After they flew past Pluto, they were going to go to another Kuiper Belt object, and we didn't know anything about it. So NASA threw everything that it had to try and characterize this object before we got there. Since then, that started with, I think, 20 of these little 16-inch Dobsonians, and then the latest campaign that the Lucy mission team did had over 100. So this has been a growing thing. Why are you talking about this? You haven't told us your qualifications. Well, I've been on a couple of these trips, and that's what I'm here to talk about. So this first one that I'm going to talk about is New Horizons team. We didn't know anything about. At the time, we were calling it 2014 MU69, which has now been renamed Arakoth, which is a super cool name. Yeah. We had, so the shadow, that's a shadow. That's my mom. My mom said that. Okay, so here's the path here. We had about 20 people go to Argentina, and we had 20 people go to South Africa, and I was on the South Africa team, so free trip, woo! We show up, we get to Cape Town. It's a lovely place. You should all visit if you can. They split us up. I don't know anybody here. I was right out of undergrad, and I don't know. They said free trip. I said, okay. So they split us up into teams of 2 people each. They give us one of these telescopes in a box, basically, and a little stand, and they give us a truck. And they say, figure it out. And so we did. Here's one of the telescopes set up. All of our kits had a little tarp, and here's the 16-inch Dobsonian telescope on this little spinning mount. It did have a motor. We did have a generator. We weren't doing this like the olden times, so that was great. And we just practiced for a few days, just trying to get on the field. It's easy to observe occultations because all you have to do is measure the star, and stars are relatively bright. But you would be surprised how hard it is to just get a brand new system and make it work. So that was a fun time. After a few days in Cape Town, we moved up a bit. This red line was the predicted center of the body. And then we split up into I think it was 2-kilometer tracks, basically. And so the idea is if we're wrong about the body center being here, then one of these other guys is probably going to catch it. So we moved from here, we went there, and then we all were told, okay, go and find somewhere to set your telescope up. And the way that they told us to do this is go on Google Maps and figure it out. So this pink line was the track that I was assigned to. We zoom in a bit. Oh, look, there's a town there. That's good. I don't really want to be in the middle of South Africa by myself. Zoom in a little bit more. Okay, so most of the town's up there, but there's some stuff down here. Okay, keep going. Okay, so there was a sports field here, but it had too many lights. Lights are bad for astronomy. Bad. This hotel here had a big field behind it that looked good. So we went to the hotel, we knock on the door, we say, excuse me, we're astronomers with NASA, which, it gets you in anywhere. Yeah. Can we use your field? They said, sure, awesome, that's so cool. Watch out for the horse, which is a whole nother story. Ask me about it later. But that's where we wanted to set up. Awesome, cool. So, okay. We get to the place, it's observing night, we're standing there, I'm standing on the case holding up a tarp to hide the telescope from the wind and the lights of the surrounding town. It's this whole ordeal. The horse tried to kill us multiple times. But we did take data at the exact time that the occultation was predicted. You can cheer. Thank you. Except nobody observed anything. These are all flat lines. So you might think, well, that's horrible. You should quit and give up at science. No, because failure is a part of science. And without that, they wouldn't have refined the orbit of the object enough to then, a month later, go and actually observe the thing. And when they, a month later, went and did another occultation, all of these colored lines are the different tracks that they had. And then look at that shape. That's not a circle. This is how we found out that Arakoth was a binary asteroid, through the magic of occultations. And then later on, when New Horizons did it flyby, bam. That's the same shape. Yeah. So even though we specifically failed, the project as a whole got what it wanted. And that's really all that matters. So, March 2022, fast forward, the Lucy mission team, a different mission, they're going to, what, 7, 8, 9, 100 different asteroids? Yeah. And so they're doing this massive occultation campaign to try and get any information they can about any of these objects. And so they say, hey, Anicia, we know you did one of these like way back when. Are you interested? I say, oh, hell yeah. And so what we're going for is, this was the shape of one of their asteroids, Polymele. This is a shape model that came of it. It looks like a flat pancake bean. But they noticed in March 2022 that something else was also blocking light a little bit after the body that they were actually going for. And so they were like, hey, is this a moon? Because that would be super awesome. So they do this massive campaign. Where are we going to go? I'm down for anything. You know, I'm crossing my fingers hoping for, you know, Latin America or something. Yep. Kansas. Yep. I got to go to sunny Kansas in February of 2023. It sure was. So luckily, SWIRI, Southwest Research Institute, has another office in Boulder, Colorado, near Denver. So we fly out to Denver, and then we get to the shadow path. I was actually lucky because they said if the weather was bad, we were going to have to go up to, you know, Michigan or something. And in February, I'm from Texas. I don't want to do that. So yeah, we end up in Kansas, the same kind of thing. They say, here's all the tracks. You're assigned your track with your 2-person team. We did our little test run for the first couple of days, and then we go and we're supposed to find our observing site. We started out in Salina, Kansas, which has 3 hotels for the hundreds of us. And this is 100 different tracks. That's 200 people. They're really, really trying to find this moon. This was my particular track, and Google Maps really wanted me to, you know, take someone home with me, someone being a ghost. Because you want to get, when you're looking on Google Maps for an occultation site, you kind of want public lands because, you know, then you don't have to go ask the person, no one's going to accidentally shoot you or whatever. Along my path, there is this cemetery, and this cemetery, and this thing that's called a park, but it's actually a cemetery. And so we decided, you know, that's not for us. This is not why we came on this trip. Let's, you know, test our luck and go on the side of a public road and hope that no one tries to get us. So we ended up right here, right on the line, because we're really good at our jobs. And we also had this is trees here, right there, that we provided wind cover so that our telescope wouldn't get shaky. And so we do the same thing. It's not nearly as eventful as the one that I did in South Africa. There were no horses. There was a coyote, but he was more afraid of me than I was of him. And we ended up, woohoo, finding the little tiny guy. So here's all of our tracks. These few ones here between these 2 green lines were able to get the main body. Woohoo. And then this one line in yellow was able to get one, it's called a cord of Sean. And it's named Sean because they like Sean the sheep. I don't know, I'll go with it. But this was a very, very, very successful occultation. And just for a comparison, in 2022, when they were only trying to get the main body, they just happened to see Sean here. And then, again, all of these lines are the different tracks and the different observers that they have. And then they really went all out here to try and find it again. Here he is, up here. Yeah, they covered their bases, and we got what we wanted. So, yeah. occultations are super cool. You all agree with me. And what can you do to, get in on this? Because this is really awesome, cool science. Well, there's a couple of ways, actually. If anyone's heard of unistellar telescopes, it's like a completely automated something telescope. This is actually one of their observers observed in occultation. You can see the star dims out. That's really awesome. They have a bunch of citizen science campaigns where they go and they basically organize people to go and observe these occultations and get cool science results out of it. And it's like $2,500 for a telescope is a lot of money, don't get me wrong, but to get an awesome science result like that, that's kind of like a good deal. The other thing is IOTA, the International Occultation Timing Association. They're a bunch of really cool people, and they all have their own telescopes, and basically they just organize themselves and go out and observe occultations all the time, and they're just awesome, cool people. But they have the complete guide to observing lunar grazing and asteroid occultations. They wrote that. They even sell a camera timer system so you can get super accurate information, and they even have a journal if you want to publish your scientific results. And again, they're really cool people. And that is apparently all that I wrote, so.
All right, bear with us. All right, great talk. Thank you, Anicia. Questions, please text your questions to the number, or I haven't gotten a lot, so we can open it up to the floor if you're online, though hopefully you can see the number well on the screen. If not, just type it into the chat. So the only two I've gotten so far are about the horse.
There was a horse. He thought it was his field. No, we get to South Africa. NASA is very against liability, so each of us is given an armed security guard, right? So my team of two has these two big dudes, combat armor, whatever. Luckily, the only thing they had to do was chase off the horse, because the horse really didn't like that we were there. And again, I'm standing like this, like with a tarp, trying to shield my telescope and protect my precious science data. And this guy's, ready to go. I guess that's the whole story. I could have just said that. Okay.
All right, anybody? Okay, I'll come to you.
Did y'all have a shroud in the kit? I noticed that the middle of the scope was bare.
No, and that's what the tarp was for. No. These were meant to be, it was meant to be a very cheap system that they could buy many, many of and just deploy. And so, like we learned when we had the trucks in South Africa, we're going over bushland and stuff, and when you pull your telescope out after that, the mirror fell off. Or like it's not collimated, or like one of them I think actually cracked. Like this was a brand new technology basically. And so they did it as cheap as possible, and you made do with what you had, AKA a tarp.
How often do occultation trips take place?
Oh boy. Oh, everybody should go see the eclipse in San Antonio, Texas. There's one on April 8th, and there's also one on October 14th. Okay. Occultations happen all the time. Ignore all of this. Okay. Here's all of the occultations that were available between June 15th and June 25th. It's many. These are all the occultations you can go observe today. if you guys want to just, run to North Dakota after this real quick. Occultation trips, like the ones that I were on, that are NASA sponsored with all this stuff. Recently, they've been every few months, but it really just depends on what the need is and what needs to be observed and when the orbits are aligned just right with the star to occult.
How did you become interested in these occultations?
How did I become? Well, they're cool, so there's that. No, I think like many things in my life, it just happened, and then I did it, and it was awesome. I was working somewhere else at the time, and they said, hey, you want a free trip? And I said, okay. And then it ended up being really cool, and I met a bunch of really awesome people who, opened doors for me in the future, so it was a good deal.
Can anyone go on these NASA-specific?
Yeah. Recently, so like with the last Polymalia one, where is it? We needed 200 people for this one, so they had a bunch of randos. Like normally it's the same, it's the occultation people do occultations, right? But here they were like, we'll take an undergrad from anywhere, or we'll do this from anywhere. You just have to like know somebody to get your foot in the door, and then basically anyone can do it as long as you know how to operate a telescope. That's kind of the main thing that they care about.
What do we got online?
Okay, you ready for the negatives on this one? Why doesn't Dr. Arredondo not like the movie Armageddon?
Why does Dr. Arredondo not like the movie Armageddon? I think my uncle wrote this in. Was his last name Arredondo? Okay. I just don't. I dislike most space movies because they're wrong, but thanks, Uncle Carl.
All right, well, this will be the last one, because I like this one. It's about the data. Is it immediately, the minute you take this and you get the data, is it like, okay, we know what's going on, or how much processing after the fact needs to be done?
Yeah, that's a really good question. So, like, each team has their little laptop and they get their data, but obviously if you have that many data sets to parse through and to kind of correlate with each other, it takes a long, long time. But then I think a lot of people will go home, night of and just process on their own, just because you want to be the one that got it. But so this one we observed in February of this year, and then they gave the results out in June. So kind of fast, kind of slow. It depends on what you're used to.
All right, well, let's thank our speaker once again for talking about occultations and shadows. And now we will go on to our 10-minute break. So that brings us to resume at 7:50. Enjoy your break.
Check, check. I just need to... Check, check. Check, 1, 2, 2. Ch, ch. Check. Is this good enough? Okay. Check. Check. 1, 2. Okay. Check. Check. Is it? Sounds less. I mean, I don't expect it to be completely quiet.
Testing. Oh? Hello. Please end your conversations now, or security will escort you out of the premises. I don't know the words to that song. What? Oh. All right, everybody. We're back. It's been 12 minutes. We didn't look at the clock. Caleb Gamar.
All right, so for tonight's edition of Astronomy News, first and foremost, what is up in the skies for July? So the map that you see here is for the nighttime sky as it appears around 10 o'clock p.m. throughout much of the month. If you look over toward the western horizon, you will see the planets Mars and Venus over on the setting side. So do make sure you get a good look at those, especially the planet Venus. If you have a backyard telescope, look at Venus throughout much of this month, and you will see something that looks like a little tiny crescent moon. You are seeing the nighttime side as well as the daytime side of the planet Venus. What is happening, of course, is that the planet is revolving around the sun just as we are, but it's, of course, in the inside of our orbit. So as it keeps going around the sun, it winds up going basically between our line of sight to the sun. And so as the month progresses on forward, it will become even more of a crescent, and then of course, eventually it will get very, very close to the sun in the sky, and you'll no longer be able to see it quite so well. So please do get a good look at the planet Venus. Very hard to miss, extremely bright. Probably the brightest star-like object that you will see in the sky. Now, for those of you with a pair of binoculars, scan across the Milky Way in a good dark sky, and you will see many nice open star clusters and star-forming nebulae. For those of you armed with a telescope, look for the Ring Nebula. Find the star Vega. Very, very easy to find. Just don't look over toward that eastern half of the sky. Find the stars of the asterism we call the Summer Triangle, Vega, Deneb, and Altair. Vega, again, the one that's, if you're looking south, most to your right-hand side. And there's a little parallelogram-shaped constellation there. And in the last bottom two stars of the parallelogram shape, look right in between those two with a telescope, and you will see this little kind of fuzzy grayish-green orb in the field of view. That is the Ring Nebula. That is a star that at one time was like our own sun, became a red giant star, then started sloughing its outer layers away into distant space, leaving behind just a little tiny white dwarf star in the center of the cloud and the gas shell on the outside. That glowing grayish-green object you see is that gas shell. It's about 2,300 light years away, so you're looking at it as it appeared about 2,300 years ago. Very long time ago. So first in the series of news stories, this one really caught my eye. The MAVEN mission around Mars has been operating there for almost 10 years, not quite. We're heading up on that anniversary pretty soon, though. And in kind of the lead up to that anniversary, many of the investigators working on the MAVEN mission released this composite image of the Martian surface at two different times of its year. One was during the southern summer season there at Mars, or at least approaching southern summer. The other one during the northern winter. In this case, it is in the ultraviolet. So MAVEN does have an ultraviolet imager on board, and a series of these ultraviolet wavelengths were selected to produce this, or these two composite images, I should say. In the composite images, the blues and purples, that is mainly atmospheric ozone that you're seeing in those images. Some of the other aerosols appear as more of a white or blue color. Of course, ices appear that white color. Surface features appear in shades of green. So very, very fascinating image. Again, good look at that if you get a chance. Search online for MAVEN images of Mars, and you'll find it. Now, Bepi Colombo, a mission that is a rather interesting venture to Mercury. It's a European Space Agency-led mission, has just recently made its third close approach with Mercury. It has to do a series of 6 close approaches with Mercury before entering orbit around the planet. So it very recently, just in the past month, it was around 19 June, so you can see the timestamp there, made its third close approach with Mercury, 147 miles altitude above the surface at closest approach. So you get a really great close-up view of Mercury in a very interesting way. You can see parts of the spacecraft in the foreground. So it really looks like you're riding along with the spacecraft as it passes by. So again, keep watching that mission. It will be 2025, though, before Bepi Colombo actually enters orbit around the planet. Now, just this past Saturday, the Euclid mission launched into space. It is a space telescope, wide-angle imaging space telescope designed to observe very distant galaxies out to about 10 billion light years. The idea is to map the skies, basically map the location of many of these distant galaxies, not only in spatial location, but also in time location. Again, when you're looking at these galaxies, you look farther back in time. So you're getting this kind of space-time mapping of the galaxies, if you will, and this will give the astronomers that are using this mission for their investigations an idea of the structure of our universe to understand distribution of dark matter, dark energy, etc. It will, much like the JWST, James Webb Space Telescope, venture out to the L2 point, that kind of interesting little balancing point there between the Earth's gravity, the Moon's gravity, Sun's gravity, all of that. And yeah, and it will do its mapping mission out there. So it'll take a little while to get there, though. 1 to 3 months basically is the time range there. Yep. And then one very interesting finding just announced today from the James Webb Space Telescope. The telescope was used to observe a couple of supernovae. These two are in the Fireworks Galaxy, NGC 6946 there. And in these observations, it was apparent that there was a very large amount of dust in the region near these supernovae, and this dust actually does originate from the supernova, from these supernova explosions. And this lends credence to the idea that in the very early universe, supernova explosions kind of seeded the very young galaxies with dusty material. The reason why is, of course, these are a little younger supernova, and these are some of the first that we've been able to really observe this well beyond the supernova 1987A, which is a little bit closer into us. And again, it's about the only example, again, pre-James Webb Space Telescope observation. So a very fascinating discovery announced today. And then just a couple more JWST images to leave you with that I'll cover very briefly. One, the Orion Nebula image that you see here, and in this image there's this small protoplanetary system forming that is a very interesting object because in the spectroscopic examinations of this, they found methyl cation material, and this is basically a carbon-hydrogen compound, very key to understanding the origin of life. I should say it's life-adjacent materials, should we say, in the formation of solar systems. And then finally, this image of Saturn right here, very fascinating image. You notice the rings show up very brightly, but the planet itself is rather dim. The methane content in Saturn's atmosphere absorbs those infrared wavelengths that the Webb telescope is designed to observe, but the icy rings show up very, very brightly in that wavelength band. Last but not least, a reminder of the solar eclipses that are coming up over San Antonio. The annular eclipse is the first one. The annular eclipse, you will not be able to see it without the eclipse shades on, so make sure you have your eclipse shades for this annular eclipse. The moon passes in front of the sun, but not in such a way as to block out the sun entirely. You just get this shadow right here. So again, that is visible over quite a bit of San Antonio. That's this gold path right here. So you know you'll be a little hard pressed to not be in the right spot for that one. Now for the total solar eclipse, so coming up on April 8th of 2024, you have to be in the right spot in town for this one. The path of it, which is marked in purple here, bisects the city, kind of going northeastward to southwestward. So basically, if you're on the kind of the northwest side of town, you'll be able to see it well. If you're on the southeast side, you probably won't be able to get the full experience. So make sure to look up online exactly where that path is and be in the right spot on that day to see it, or else you will miss out. And with that, that concludes Astronomy News. Thank you very much.
Thank you, Caleb. I have the honor of introducing our next speaker. Originally from Pennsylvania, Elena Dolgas attended Florida Institute of Technology for her undergraduate in planetary science. She's a soon-to-be master's graduate of the UTSA SWIRI Physics program, where she has studied the composition of the lunar surface. Her future plans include pursuing a PhD at the University of Central Florida. Everybody, I give you Elena Dolgas. And your word.
My drinking word is moon, but I don't use it that often, I promise. Just in the title. So, great clips. The moon is getting a new dew. There you go. No? Okay, so what is CLPS? Not the haircut place, but the Commercial Lunar Payload Services Initiative. It is in direct support of the Artemis program, or NASA's return to the moon. So the first time that humans are going to be on the surface in about 5 decades, so it's been a while. The goal of the Eclipse program is these rapid, frequent deliveries to the surface. So it is a bridge between NASA and individual companies. So a lot of this work is getting offloaded onto these companies in order to get a lot of deliveries in a short amount of time. And then all of these landing sites that they are going to are of high scientific interest. So they're areas we don't really understand, either their formation or their composition or even both. And then on the bottom there, we have model images of the landers that are going to be used. And most of these are going to be used more than once because these companies won contracts for multiple missions. So a map of where these deliveries are going to go. So this is for about the next 3 years. However, it does keep getting delayed. It was supposed to start in 2022, but we're now in July and nothing is launched yet. So hopefully something's going to start soon. But the first is going to be the Gruithuisen domes. It's actually going to be in this region right below them. And it is a volcanic region. And then another area right below them is Reiner Gamma, which is a lunar swirl. And this is a region of magnetic anomaly. And then the third, you can see this dark area is kind of separate from the other dark areas, making it unique. So that's why we want to go there. It's called Mare Crisium. And then that center spot is where Apollo landed. So it is a no-fly zone, basically. So all of these CLPS missions have to go further away from this area because it is protected. So the science that we did at Apollo will not be disturbed. And then on the bottom, we also have about 4 missions to the South Pole. It's supposed to be 5, one's canceled, they went out of business. But it's going to be at least 4 missions to the South Pole, and that is the most directly related to Artemis, as that is going to be the base camp for the astronauts. So the first, this one's in progress. It was supposed to go in 2022. It is now in August of this year, but there have been no updates yet, and that's supposed to be next month. But what it's going to do is look at these features that are lunar red spots, which means they're high albedo and they're strong UV absorbers. So these dome-shaped features are weird volcanic melts. We're not really sure how they formed because when it's on the Earth, it's usually with water and plate tectonics, and the moon has neither. So, there you go. So that's why we're sending not only 1 mission, but 2. So we're sending 1 to this region below them for comparison, and that's the peregrine lander that's pictured going to Sinus Viscosiditis. And then there is an additional mission, Lunar Vice, that is going to land on top of a dome, or attempt to land on top of a dome, because it's never been done before. And it hasn't been decided yet which one it's going to. But that is actually my work at UCF is going to be working on that project. And then the next site we look at is also a bright feature, so also high albedo. It's a lunar swirl, so it's a magnetic anomaly. However, the reason that it's so bright is kind of debated. It could be because this magnetic feature is shielding the surface from space weathering, or it could be that this magnetic interaction is actually lifting the dust and changing the surface in that area. So this is just a concept image. of the rover that's going to go to this area, and it's called Lunar Vertex. So it's going to rove around and take measurements of both the surface as well as the magnetic field. And then the last of the non-polar sites is Mare Crisium. So it's this sea on the moon that is separate from all the other lunar seas. So that's what makes it so unique, is it's kind of isolated from everything else. And then, as you can also see, it's pretty flat, which is weird. There's like 3 or 4 craters, but other than that, it looks like lava just kind of poured in there and smoothed everything out. Of all the CLPS sites, so all 11 or 10, we do have a sample. There was a Soviet Union mission back in like the 70s that took a drill sample at that very corner. So we do have some soil. However, this isn't enough really to look at the whole area. As you can see, it's pretty varied. And this is an example of the Blue Ghost lander. It's also a 2024 launch date, but I just checked today, there have been no updates in like a year. And then perhaps the most important of the CLPS sites is going to be the South Pole sites. So this is the most likely the location of water ice on the moon. It is going to be in these permanently shattered regions, or PSRs, and that's the darkest regions. But at the same time, we also get a lot of sunlight. So the missions that are going to land there, either 4 or 5, whatever it's going to be, are also going to be able to use that as solar power. And the same with Artemis, is it's going to have access to both dark regions with ice, light regions with sunlight for power. And then the analysis that I'm going to do doesn't really focus in on these sites because they keep getting changed and re-announced, and like the one went out of business, but we're going to look at it as a whole. So what do I use to look at the lunar surface? LRO LAMP, which is the Lunar Reconnaissance Orbiter Lyman Alpha Mapping Project. So it is a spectrograph, so it is recording the reflected photons from the moon's surface. So in the daytime, that's from the sun. From the nighttime, that's from stars. And specifically, we look at the off-band and on-band ratios. So these, when the mission was first launched, these focused on ice reflectivity, but it was like a happy accident that it also turns out this ratio is good for composition analysis. So high off-on ratio values could indicate feldspars or plagioclase, and there's also a chance that it can mean reduced space weather. So the first site, the Gruithuisen domes, the squares you can't really see in the white, but they match directly. So I looked at both of the domes and then the Mare region below that the other mission is going to go to. And we can see that the domes are brighter than the Mare by a good bit. And if you take the average value of those pixels in that square, it is a significantly higher amount. And then same thing kind of for Reiner Gamma, but for different reasons. So how we saw in the domes, the bright ratio is likely because of feldspars, because we think they're plagioclase rich. But in the case of the swirl, we think the bright area or the high values is because of this space weathering shielding that is going on. So the surface is optically immature compared to its surrounding area. Then lastly, Mare Crisium is kind of boring. It's the most uniform, but that's expected because it's a mare, so it's darker than the other regions. It's not a high albedo feature. But we do see with the bottom left corner there, that is the Picard crater. It does have some higher albedo values. However, the CLPS mission is not going there, so it doesn't really matter. And then the South Pole. So the South Pole has been previously analyzed by several other people in the LAMP team. So on the left there, we have an example of a night side map. And in the paper from 2022, we highlighted the permanently shattered regions, so where water ice is most likely to occur. And then the right is the map that I made just this year, which is the day side map. So it doesn't focus on the water ice as much as we see these brighter areas where if a mission was to land there, it would get good sunlight if it landed in those brighter spots. So overall, this is a new age for space travel. It's getting people excited about the moon again, like as it has been over 50 years since we've been there. It's good to get a new generation excited, or people that watch the moon landing, they will get to see another one in their lifetime. So all of these, I only highlighted 4, but there are some repeats and there are more to be announced. All of these CLPS missions are in direct support of this, as they're going to give more information about the lunar surface. So then I highlighted Artemis 1 to 3 here. Artemis 1 already happened. It successfully demonstrated a rocket by doing a 2-week orbit, and then 2 and 3 are upcoming missions. Potentially, Artemis 2 is going to be in 2024, our first crewed lunar flyby since Apollo, and then Artemis 3, hopefully 2026, humans will return to the lunar surface. And with that, thank you, and any questions?
Well, thank you, Elena. That was really good presentation. And yes, we do have multiple good questions already. Can you elaborate on the Apollo no-fly zone?
So we had Apollo 11 through 17, but skipping 13. But for all of those missions that landed in kind of the same area, I can go all the way back. Yeah, so kind of all the same area, and at least in this projection that I use, it's kind of in the center. So we don't want to land any rockets nearby, because then like the plume, the exhaust that's coming out of these rockets could either get on the lunar modules we had there, or just in the general, like the previous landing sites. So the science that we're doing on these samples, we don't want interfered with new landings.
What are feldspar and plagioclase?
So if we look at the moon in kind of 2 categories, we have either silica-dominated rocks, or like silicates, or non-silica rocks. So silica-dominated is these plagioclase, or plagioclase feldspar is the whole like subcategory name. But that's what we think would have to form with water. Yeah, for the domes, we think that for these to have formed in that kind of shape where they just kind of spread out, like they're not really mountains, they're not really like peaks, they're just kind of flat shapes, then it would have had to be a combination of this silica mixed with water.
What is an albedo ratio?
So the albedo ratio is one of the maps that LAMP takes in. So there are several products that this instrument produces after it takes in data. The raw measurements are these photon counts, so just the reflections of the surface. So one of the products that we make out of these maps is a brightness map, which is just how bright the surface is. And then we also have the illumination, which was this like illuminated by the sun, or the stellar illumination if it was a night side. And we combine that brightness with illumination is when we get albedo maps.
Which one of the CLPS missions are you most excited for?
Well, I'm most excited for the one that's paying for me to go to school. So that's the one that's going to the domes. And also they're just really weird because, like I said, when we see these on Earth, it's water, and there's no water in this area of the moon at least. And also that we are aiming to land on top of a dome is going to be a really big scientific achievement, hopefully to, if it's successful, to coordinate that type of landing on this, small little area.
How long do we expect many of these rovers and instruments to last?
Good question. I'm not totally sure, but it is a lot of these companies' first try. So I'm going to put it out there, it's not assumed that everyone's going to work. So there is so many because some might be failures. It is the first time a lot of these companies are doing this, but that was the whole initiative, is new technology, new demonstration, basically like put your brain together, let's get something new engineered, and if it works, then we can use it for Artemis. If not, then oh well. So, undetermined timeline. So NASA put out contracts, and these aerospace companies had to bid on them, and then they got awarded them or not. And these aerospace companies are just in charge of the vehicle, so the lander itself. But then everything on board is a mix of NASA, company, academia. So it's a weird joint effort that they don't usually do.
How do we know that Reiner Gamma is a magnetic anomaly?
So from the, not just from LRO, but from these orbiter missions we have, we can pick up on these signatures. And like even Apollo had magnetometers that it could pick up on this magnetic signature as well.
Can you list some of the companies, and are there any Texan ones?
I believe there are. The main ones that I highlighted, or at least the ones that got the most awards, like as in they got awarded more than one landing site, was Astrobotic from Pittsburgh, where I live. Novacy, I don't know where they're based out of, and then Firefly Aerospace. So if you know Firefly or Intuitive Machines, those are the other two that got multiple contracts. I believe there is Sweary Instruments that are going to be on some of these, so we have that connection. But like Texas-based, I'm not totally sure.
All right, let's thank our speaker once again. We'll talk about the moon. Oh, that's right, I'm in charge of the computer. All right, this says trivia time, but we all know that means break number 2 before trivia. So yes, so we will take our next break, which will be roughly 5-ish minutes, may go to 10. But we'll pass out trivia sheets. For those of you who can't stay for trivia, thank you for coming. For those of you who can, we will pass out sheets and writing utensils for you all. Remember, max group size is 4 per team. And tonight's theme for the trivia is solar system and culture. So yes, so during this break, we also welcome you to come look at our merchandise up here on the table. We have some eclipse glasses if you would like some solar eclipse glasses. And our trivia prizes tonight feature an LRO lamp mug, the instrument that Elena just talked about. You can win a mug of that instrument. And pretty moon postcards, courtesy of Robert Reeves. Thank you as always. Makes it easier to grade, and we can all get out of here quicker. All right. We'll start off with question 1. The first animal to reach the Earth's orbit was a Soviet dog that flew on board Sputnik 2. With what name? Was it A, Belka, B, Chernushka, C, Laika, D, Marfusha, or E, Strelka? What was the name of the dog, the first animal, the first being, the first living being in our known solar system to reach the solar system? What was their name? The dog was a pioneer. And unfortunately, I think it was a one-way trip, so.
If I may, they had a comic written recently about that animal. It was pretty interesting, actually. Little tidbit of information. I don't know why I gave it back to you. I'm going to take it.
Oh, yeah.
All right. If need be, we will come back, but at the moment we will move on to question 2. The innermost dwarf planet named Ceres is named after Ceres, the Roman goddess of what? So what does Ceres is named after Ceres, after, of course, the Roman goddess Ceres, and what is Ceres the Roman goddess of? Is it A, beauty, B, wisdom, C, war, D, agriculture, or E, dwarves? Might I remind you, the Roman goddess.
I can't believe it was the Roman goddess of Ceres.
Wait, Sam, why is it worse than Pluto?
Oh, yeah, it does say worse than Pluto. Wow. Wow, we have some hot takes here. All right, everybody good on this one? We're moving on. Question 3. What's the world #1 best-selling science fiction novel? Number 1. Is it A, Dune, written by Frank Herbert, B, The Time Machine, written by H.G. Wells, C, The Martian, written by Andy Weir, D, The Hitchhiker's Guide to the Galaxy, written by Douglas Adams, or E, 1984, written by George Orwell? Which one of these was the #1 best-selling science fiction novel?
I wonder if recent times have updated the question or have updated the answer. But I think I know which one it is. This one takes some consideration, takes a little back and forth. All right, the conversation is lulling. We're going to take that as an opportunity to move on to question 4. Planetary origins. 6 of the current planets do not have an official discovery date, as they have, more or less, always been known to exist. Which celestial body is the first to actually be discovered, i.e. has a discovery date? Is it A, Ceres? Who are they the Roman goddess of? We will find out. Is it B, Mercury, C, Pluto, D, Neptune, or E, Uranus? I don't think I actually know the answer to this one. This one is an interesting question. That's a good question, Sam.
I knew the answer to it, no. But I did. Okay, yeah. What would you say?
I would.
All right, question 5. Yeah. Disney in space. Walt Disney's famous dog, Pluto, right here, was released in 1930, named after the then recently discovered planet Pluto. What was the original name supposed to be besides Pluto? Is it A, Duke, B, Buzz, C, Rover, D, Fido, or E, Galaxy? Which name was going to be the original name for Pluto before the planet came around? Disney's everywhere.
Could you imagine naming your dog Galaxy? Come here, Galaxy. Come here. Come here, you little swirling thing of dust. I would never name my dog Galaxy. All right, I think the lull indicates. Move on to the next question. Question 6. In 1825, which U.S. president proposed for a national observatory that later became the U.S. Naval Observatory? Is it A, Barack Obama, B, George Washington, C, Thomas Jefferson, D, John Quincy Adams, or E, Martin Van Buren? Bonus. What year was it formed? Closest year is given credit. So as in what year was the national, or the, wait. So it would be the U.S. Naval Observatory. What year was the U.S. Naval Observatory formed?
And write it next to the multiple choice letter on the same line. Don't write it in the bonus box. Write it on the same line, please.
I'm not going to lie. I didn't even know Martin Van Buren was a president. I'm going to be honest. The mutton chops. Yeah. All right, we're going to move on to the bonus question.
We'll go back around if anybody needs it. So, all right. The bonus, the big bonus tonight is, this is where the culture really comes in. This is a musical question for those of you who love classical music. Yeah. Gustav Holst's The Planets, Opus 32, is a 7-movement orchestral suite where each movement is named after a planet of the solar system, not including the Earth, by the way. In which order is the suite played? So the order of the movements in this opus, from 1 to 7, give us the names of the planets in that order, correct order. Of the composition. It's a very pretty composition, if only. It would take a long time. You know how long orchestral movements are? Perhaps AOT can do a night at the symphony. We can get Brittany to do the cello.
I know we're all thinking about the bonus question. This one's going to take a while. But does anybody need a question repeated?
All right, so while you all are thinking about the bonus, we'll run through. So, reminder, so the first question is about the first dog or animal in space, which was a dog. What was the name? Thumbs up if you're good. Good. Dog. The Innermost Planet series? What? No, Innermost Dwarf Planet. Named after.
The Roman goddess Ceres. What is the Roman goddess Ceres? Means after Ceres.
Good, everybody? Good? Speak out if you're not. I guess we'll do that. Yell if you're not. Okay. Question 3 about the best-selling novel. Yell if you're not good. Question 4, planetary origins. The discovery of the first one to be actual discovered. Yell if you're not good. Good? All right. Disney in space. Pluto. What was his name if not Pluto? Yell if you're not good. All right? And the observatory. Both who was the president that established it and when was it built. Yell if you're not good. Good? All right. And then, of course, bonus. Is everybody done with the well, actually, at this point, when you're done, come up, bring your answers. We'll take a quick break to grade them, and then we'll announce winners and prize. And bring your pen. Bring your pen. Let's go through the answers for tonight's questions. The first question about the first dog in space, the answer was Laika. Many people got that right. So I guess you all saw the whatever comic or no, yeah, comic. What? No? Oh. Futurama? Okay. All right, question 2.
Who Ceres was named after Ceres, the goddess Ceres. Who is the goddess Ceres? Naming the minor planet Ceres. Agriculture. I didn't know that.
Agriculture. It was agriculture. All right, question 3. Question 3, which was the book. Which book is the #1 best-selling science fiction novel? It is The Orwellian 1984. According to Wikipedia and another website. It's been double referenced. The main so we got 2. But think about it. It's in a lot of schools. So if you count how many books a school has to buy, that's a lot. So, you know.
Question 4, which I do not remember. Oh, yes. Which celestial body has the actual date attached to it? It is Uranus, 1781. And yes, after some thought, I realized what the question was asking, but yeah, Uranus.
All right, question 5. The answer, this one is about Pluto. The dog was named after Pluto, the recently discovered planet, but if the planet had never been discovered, he would have been named Rover. Just wouldn't have been as fun. Mickey and Rover. That's just, that doesn't. Mickey and Pluto, that's more like it. All right. And,
And question 6. Oh, yes. Which president was sitting, right? Yes. John Quincy Adams. That old guy. Oh, yes. Did anybody get the year? Oh, wait, Sam?
1944. 18. 18. I'm jet lagged. I can't remember anymore. 1844. Oh yeah. The big bonus, which was to list the planets in order of the opus. And by movement, yes. It's an interesting order, actually. It ends up being that the outer planets are in the correct order, but the inner planets were in reverse order. So you have Mars, Venus, Mercury, and then the normal Jupiter, Saturn, Uranus, and Neptune. So if you got close, pat yourself on the back. If not, then that means no. Everybody, listen to the opus on your way home. Mars apparently is the most well-known of this opus. It's ubiquitous with this planet's composition. It's very nice. So tonight, as usual, we have our top 3 prizes. And for third place, we have some Celestron swag, so like a case that has some chargers in it and some hand sanitizer. And we also have some NASA trading cards. Yes. So our third place winner is Solar Stout. Congrats. All right, our second place winner. So our second and first place winner were really close. They actually both guessed the same year on that observatory question. So that was unfortunate for tie-breaking purposes. However, one of them did better on the big bonus of the order. So the one who didn't will get second place, and the mug, our beautiful LRO mug, LRO lamp mug, which, fun aside, I know not all of you can see, you can come take a look, but it's a lava lamp. It's the official logo for this instrument. So if anybody says NASA's not creative or cool, you can tell them to shut up. In second place, Star Masters. Come on up, get your prize. Congratulations.
How many trading cards do you want? You probably have to.
All right, before we get to the first place, we have, as usual, our internal student composition between the grad students and the undergraduate students. And it is my displeasure to announce that the grad students did not win. The undergrads will receive some of these cards on the way out. Come on. All right, let's, without further ado, the first prize winner for this evening, who will receive a bunch of these postcards. Once again, thank you, Robert Reeves, who I believe had to step out, of the moon. And on the back, they are postcards. So if you ever want to send them to somebody, you can. They have the lines and everything and explain a little bit on what you're seeing in each one. Beautiful images of our moon. The winner is Foul Manor. Yes? Come on up. Congrats. Congratulations. And that brings us to the end of this evening. Thank you all for coming out to our July edition of Astronomy on Tap. Our next Astronomy on Tap will be Wednesday, August 2nd. We hope to see you all there. Be sure, I'm sure you all have paid already, but thank you once again to the Blue Star Brewing Company for hosting us, and tip your waiters and waitresses very well. Get home safely. We'll see you soon. Oh, and merchandise and eclipse glasses up here.